Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 183, and today is our lesson number 248. The very last problem on page 183, number 119. Now here's the deal. The problem that you see in the book there, at the bottom, at the end of the, on page 183, the very last problem, and the problem that you see on the blackboard are not exactly the same problem, but they are similar problems. This extra problem is just for some extra practice. So here's how the problem goes. It says, so read the problem with me in the book, read the problem in the book, and we'll make the changes as we go along so you can make the parallel as to how similar they are. In a certain game, a large container is filled with red, white, blue and green marbles. Each worth 2, 3, 5 and 7 points respectively. You see how similar they are? They are very similar. And then he says a number of marbles are then removed from the container and their points value noted. So we have taken a handful of marbles based on their colors, we have noted their points value, and then we have taken the product of all the points values of the removed marbles. It turns out that the product of all the points value of the removed marble equals 63,000. The question simply is, how many of each types were removed? That's all there is. Now the very first thing we should notice here is the fact that the points value of the marbles that is given to us here is 2, 3, 5, 7 is there for a reason. Do you see a pattern here? Do you see anything common characteristics of these numbers? 2, 3, 5, 7. These are prime numbers. These are prime numbers. So essentially all this elaborate mumbo jumbo that they're giving you, they're basically asking us to find prime factors of 63,000. That's all it is. Now if you try to figure out the prime factors of 63,000 the way it is, it will not be an easy task. What we should do, smart thing to do here would be to break it up into manageable parts. Let's break up 63,000 into 63 and 1,000. In other words, instead of trying to find the prime factors of 63,000, let's find the prime factors of 63 first, and then we'll worry about 1,000. So 63, let's divide by 3, you get 2 and a 1. Let's divide again by 3, we get a 7. 1,000, when we divide by 2, we get 500. Divide again by 2, we get 250. Divide again by 2, we get 125. Divide by 5, we get 25. And then 5 again, and we get a 5. Well, that's it. So it turns out that the prime factors of 1,000 are 2 and 5. Let's answer our question. Let's make a note here. We have red, we have white, we have blue, and we have green. And their points values are 2, 3, 5 and 7. Good enough. As we can see here, we have two marbles that were worth 3 points. Two marbles that were worth 3 points. And that means that we must have drawn 2 white marbles. We also see that we have one that was worth 7 points, which means we must have had one green marble removed. We must have removed one green marble. And then we have three twos. Well, twos are red ones. Twos are red ones. We must have removed 3 red ones. And then finally, we have 3 fives. Don't forget this 5 in the corner. We have 3 fives, which means we must have removed 3 of the blue ones. That's it, we are done. We answered the question. We are done with it. What I want you to do now is to pause the video, stop the video altogether if you have to, if you must. Pause it, stop it, whatever it takes, and do the problem that you see in the book now that you understand what to do with it. Do the problem in the book, and then once you have your answer in front of you, once you have done it, resume the video and then compare the work that you did yourself and the work that we're going to do, you and I together, for that problem. Okay? I'll give you a few seconds to pause and unpause. Alright, so let's do the problem that appears in the book. In the book it says, in a certain game, a large container is filled with red, yellow, green and blue. Okay, red, yellow, red, yellow. Red, yellow, green and blue. Red, yellow, green and blue. Of course nothing has changed. The points value in this problem are in reverse order. That also does not make any difference to us. So we have 7, 5, 3 and 2. Okay, so far so good, no big deal. And we are told that when you take all these points value and multiply them together, we get a product of 147,000. 147,000. Again, we're going to take our 147,000 and break it up into 147 and 1,000. The 1,000 part is already done, so we don't have to redo it. 147, I see a 14, I see a 14 and I see a 7. Obviously we can divide this by 7, even though strictly speaking, your math teacher will tell you that you're not supposed to do that. When you're trying to find the prime factor of a number, your job is to always start out with the lowest prime factor that you can find. And the lowest prime factor here would be 3, because you see 1 plus 4 is 5, 5 plus 7 is 12, and since sum of the digit of 147 is divisible by 3, therefore 147 is divisible by 3. But I'm going to violate the rule. What the hell, just don't tell anybody. So 7 divided by 7 you get 2 and a 1, divide again by 7 you get 3. Now had you divided by 3 to start out with like we were supposed to, we would have gotten 49 and we would have gotten 2 sevens there. But anyway, we're done. So again we have to erase all of this part because this belongs to the previous problem. So here we have red, yellow, green and blue, and they are worth 7, 5, 3 and 2. Okay, let's get going. We see 2 sevens, which means we must have had 2 red. We have 2 red ones. I see 1 3, which means we had 1 green one. 1 green, because there is only 1 3. There is 1 factor of 3, which means we must have taken out only 1 marble of color green. I see 3 twos. Twos are blues. Twos are blues, so we must have had 3 blues. And finally, I see 3 fives, and fives are yellow. That's it, we are done. So question was, how many marbles of each color did we remove? The answer is we must have removed 2 reds, 1 green, 2 red marbles, 1 green, 3 blue marbles and 3 yellow marbles. That's all there is. That's it. I will see you tomorrow, okay? Bye now.